Why do black holes warp spacetime? Have you ever wondered how something as mysterious as a black hole can affect the very fabric of our universe? The answer lies in their incredible mass and density. Black holes warp spacetime due to their enormous mass concentrated in a tiny area known as a singularity. This singularity has infinite density, meaning all the mass is squeezed into a space with no volume. This creates an intense gravitational pull that affects everything around it. According to Albert Einstein's theory of general relativity, mass and energy influence how spacetime curves. In turn, the curvature of spacetime dictates how objects move. So, when a black hole's singularity exerts its immense mass, it bends the fabric of spacetime dramatically. To picture this, think of spacetime as a stretched, flexible sheet. When you place a heavy object, like a black hole, on the sheet, it sinks deep into it, causing the sheet to curve around the object. This curvature is what we refer to as warped spacetime. The gravity of a black hole is so powerful that it bends spacetime to the point where even light cannot escape if it gets too close. This boundary is known as the event horizon. The warping of spacetime affects both space and time. Near a black hole, space curves in such a way that the paths of objects and light bend inward, drawing them toward the black hole. Time also behaves differently near a black hole. It slows down compared to areas farther away, a phenomenon called gravitational time dilation. This occurs because the flow of time is linked to the shape of spacetime, and the black hole's gravity compresses the time dimension around it. This warping changes how objects move as well. Instead of traveling in straight lines, objects follow curved paths called geodesics that bend toward the black hole. This is why you see objects orbiting a black hole or spiraling in if they venture too close. In our everyday lives, this concept helps us understand gravity not merely as a force but as the shape of space and time around massive objects. Black holes serve as the most extreme example of this principle, demonstrating how mass can distort spacetime to its limits. Therefore, black holes warp spacetime because their massive, dense centers create a gravitational field so strong that it curves the four-dimensional fabric of space and time around them, influencing everything from the paths of objects to the flow of time itself.